Hello,
Yes, good evening, sir.
Kamlesh, am I audible to you?
Yes, sir, you are audible.
Okay, okay. We will wait for 5 minutes. Let all people join, then we'll start.
Yeah, sure, sir.
Once you were asking last time about GATE exam, na?
No, sir, I was not asking. There was someone else.
Okay, okay. Okay, we will start now. My name is Sunny Kumar Sharma, and this session is a part of my PMRF TA duty. Today is the second week of our discussion of the course design of farm machinery. This course is taught by Professor Hibsur Rahman. And last week we discussed regarding MBPLO. So if you have any doubt regarding the last class, you can ask. These are the things which we taught, which we studied in last class. Once, do you have any doubt regarding last class?
No, sir.
Okay, then we will start week two discussion. Today we will study today we will study about disc plow and disc harrow. And in last class, someone was asking about the forces acting on disc plow. So these are the forces which act on disc plow. Main, Mainly, we need to the forces which are for our importance, that is moment force and thrust force, which act on the disc plow. This moment force, this, and the resultant of this moment and thrust is denoted by RH. The concept of RH we discussed in the last class. What is RS? RH? Once. There are mainly two types of forces which act on any implement. One is useful force and one is parasitic force. Useful force we denote by R and parasitic by Q. And the horizontal projection of this R and Q, when we do the horizontal projection on a plane, on the on the ground surface on a plane, we denote it as RH and QH. And the resultant of this RH and QH is PH, that is pull. And the component of this PH in the direction of line of motion is draft, which we denote as PX. So RH is the horizontal component of useful force. When we break this RH in two components in X and Y axis, we get L and S. So RH's breakdown is L and S, and M and T will give RH. Next thing is, what is this disk plow is working as a depth of A. So what is the diameter of disk at this working depth? This is denoted as dA. This this working width is important when we will design the disk plow or disk harrow, because this will decide the spacing between the disk between those disks. So this is of our interest. From geometry we will get this formula, and we will when we will solve this we will get the diameter at this depth is denoted will come as 2 root under a into d minus a. This you can do by yourself also. And this formula you can remember, what is diameter of the disk? D is equal to Ka by cos beta, where beta is the tilt angle. In case of harrow, the disks are vertical. So in that case, beta is equal to 0. And in case of disk plow, what is tilt angle? What is the value of tilt angle? In case of disk plow, Hans. Hans Raj. Once, what is the value of tilt angle?
15 to 25.
And why that value? We discussed in last class that why tilt angle should be less and disk angle should be around 45 degree. What is the reason?
So I cannot recall that.
Okay, wait. In last class we saw this graph. Here I explained that why tilt angle should be minimum around 15 to 25 and disk angle should be around 15 to 45 degrees. This graph clearly explains that thing. At greater tilt angle, our vertical force on the disc plow increases, and when we have a greater V, we will have less penetration. But we want more penetration, so we will go towards lesser V. At this point, at less tilt angle, V value is less, so that will allow more penetration. So we should have lesser tilt angle for more penetration. That is the reason of less tilt angle. And what is the reason of this 45-degree disc angle? Because less at the disc angle less than 45-degree, we have increased draft, and at an angle greater than 45 also, we have an increased draft. The reason we also discussed in last class. So 45-degree is the optimum angle for working of the disc plow. So this is the formula for diameter of the disc plow. And beta here is the tilt angle. When beta will be 0, we will have only k into a. This will be our disc diameter. But this is this is disc diameter, and disc is how what is like how many types of disc harrow is there? One is single acting, one is double acting, one is offset. So uh, Kamlesh, do you know the difference among these? What is single acting, what is double acting, what is offset?
Sir, in single acting disc harrow, I think we have V shape type of gang in which
Then
four type of disc we place.
not exactly four, means we have some number of discs, like more than, it can be more than four. And what is double acting?
Double acting, basically we extend this one shape in X shape.
Yes, that is correct. This is double acting, where we have discs here. And what is offset?
Sir, offset is like single acting only, but the
Mm.
center of it will be in the side.
Yes, understood. So this is offset disk harrow. So what we discussed, this will be our length of shaft, but that is not the cutting width. This is our cutting width. So what will be the formula if we know what is the number of discs on each gang and what is the spacing? This spacing, if we are knowing, then we can get, and what is the diameter if we are knowing, then we have two formula. We have BIS standard for getting the working width, and we also have Asabe standard. So if we are knowing the N, S and D value, we can calculate the working width of single acting, double acting and offset. So now we have questions of this week. But before going to the question, we will first design one disk harrow. After designing, all the questions will become very easy. So we will first design a single acting disk harrow of 45 HP, two wheel drive tractor weighing 2200 kg and a rolling resistance. We will take as 8% of its weight, assuming weight of harrow as 400 kg. So have you seen those lectures from NPTEL? Kamlesh, Hans and Vans. You all have seen those videos, week 2 videos.
No, sir, not completely.
Week 1 you have saw.
Yes, sir. Yes.
Okay. Kamlesh, do you have any doubt from week 1?
No, sir. No.
Okay. For designing any implement, we will first know that what is the drawer power available. For knowing that drawer power available, we must know that this is the Asabi, this is also in a Asabi standard, that from engine power, what is the power we are getting at drawer. And second thing is we will subtract the motion resistance of the tractor, because that is like creating hindrance to the tractor, and that is not of our interest. So the drawer power available will be power available at drawer minus motion resistance of the tractor. And for drawer power available we have this standard. So from engine power to the drawer we have reduction due to transmission loss. We have transmission loss and tractive efficiency and traction loss. So transmission efficiency generally we take as 0.96 to 0.98, and tractive efficiency we take as 0.85 to 0.89. So we will take some value and we will proceed. For motion resistance, it is 8% of total weight of tractor. So that will come as 208 kg, and we will assume, as it is not given in question, we will assume that this implement is working operating at a speed of 4 km per hour. So from there we will get that power required for propelling will be 3.08 HP. This is the power required for propelling. And what is the power coming at drawer? That will be 45 HP is the tractor power, and 82 is the transmission efficiency, 0.6 is the tractive efficiency. From there we will get that 22.1 HP is the power available for drawer. Now this is in HP and also taking power reserve. This power reserve we are taking for our safety. So we will multiply this available power into zero point 0.8. We are getting 17.71. From here we are getting that 14.63 is the drawer power available. Now if we are having drawer power available, we can know draft from here. How we can know? Hans Raj, we got the drawer power available for carrying out tillage. From here how can we know the draft? Okay, Kamlesh, you tell. If we got the drawer power value, 14.63 HP. What will be the draft available?
Sir, I think we have to multiply with speed.
This is the drawer power available. Drawer power into speed you are saying.
No, sir, draft into speed we have to multiply.
Yes. Draft into a speed is equal to drawer power. So draft we need to know. So we will divide drawer power by speed. From there we can get the draft available. So this is the drawer power and this is our speed. So this is our draft available for carrying out delays. From this is our design draft. Now here from here we will design the disk. First disk diameter we will calculate. For that we have formula by cos beta, and beta in case of harrow is 0. So k into a, k is 3 to 6. If we take 5 and a is the working depth, the depth of operation here is 10 centimeter. So 50 centimeter is the diameter of the disk, and some standard diameter values are there which are available in the market. That is 51, 41. These values are there. So 51 centimeter will be our design diameter. From there we can calculate spacing between two discs. Now disc harrow, which type of disc harrow it is? Single acting disc harrow. Single acting disc harrow means this type of disc harrow it is. So what will be the spacing between the disc? This is the disc spacing. For disk spacing, we have a formula 2 into a into d minus a, tan theta 0. Theta 0 is the gang angle. If this is the, suppose this is the single acting disk harrow, then this is the gang angle. We denote by beta. So if a is the working depth, we will put that a value and theta value, we will get that disk spacing is 14.74. This value is 14.74. This spacing is 14.74. Now from here we will proceed to find the cutting width. As we know that 14 into 7 4, we will multiply by, if 5 is spacing, then we will not get the cutting width. From here we can get the length of shaft, but we need to know the working width, cutting width of the disc arrow. So we have Asabi equation, that is s equal to 0.95 into n minus 2 into s plus 0.3 d by 100. This is for single acting disc arrow. From here we can get that s value is 1.55 meter or 155 centimeter or 1.55 meter. This is working width. Now length of shaft. As I told you that length of shaft for each gang. Length of shaft is, there are 6 discs. So what will be the length of shaft? 14.74 was spacing, that into 6. This is equal to 88.44. Approx 90 centimeter is the length of one shaft. Means this shaft length is 90 centimeter and this is 90 centimeter. And this working width is 1.55. This we are taking 12 number of discs. 6 this side, 6 this side. So total working width will be 1.55 meter. And length of one shaft is 0.9 meter. This side 0.9 meter. This is length of shaft. Now draft requirement. Taking unit draft as 0.25 kg per centimeter square. This is for which soil? I think this is for soft soil maybe. So for that soil, this is 0.25 kg per centimeter square. So 0.25 we will convert it into Newton, that is 9.81 into area of cross section. Area of cross section will be working width 1.55 meter into centimeter will be 155 centimeter, and working depth is 10 centimeter. This centimeter into this centimeter we will get the area into 0.25 we will get the draft. This will come as 3801 Newton. Now that is 3801.375 is for two gang. For one gang it will be 1900 or 1.9 kilonewton. And for disc harrow or disc plow, we have values for L by V, S by V, L by S. Every values for a standard 46 centimeter, 51 centimeter, all type of disc diameter. We have this standard ratios. For 51 centimeter, L by VT ratio is 1.11, where L is the L is the VT is the vertical force and L is the draft. So what draft we are getting? 1900. This is the draft value for one gang. So suppose this is draft value by vertical force. We are having 1.11. This is standard from standard table. So 1900 by 1.11 we will do. We will get that. What will be the vertical force acting on the disc? Suppose this is the disc. What will be the vertical force acting on this disc? So V by 1.11 we will do. We will get 1727. This is the vertical force on one gang, and on one gang we have six discs. So this value by 6 we will do. We will get 288 Newton. This is the vertical force acting on one disc in one gang. And weight of implement was given. Single acting disc harrow, it is taken as 150 to 270 kg per meter. So weight of whole implement will be, this is per meter and our meter is 1.55 meter. So 418.5 kg is the weight of whole disc harrow. Now what is the vertical force? Vertical force is 1727 Newton. And what is the weight of implement? 4105 Newton. From here you can see that weight of implement is very large, is large than vertical force. So this condition is necessary for better penetration of the disc into the soil. This condition is fulfilling, means our design is safe. From here we will proceed for the design, and we will first design the shaft, then we will design the frame. First thing is the design of shaft. So what was the length of shaft? 6 into spacing, and our spacing was 0.14, so 0.9 meter that we calculated earlier. 0.9 meter was the length of shaft. 0.9 meter into, and this side 0.9 meter. Now this figure is very important to understand the design. This is the normal reaction force acting on one gang on each end, and these are the vertical force acting on each disc. We will denote it at suppose V, but V value we know, we have also already calculated. S is the spacing between two discs. This RA, we have spacing S. We multiply it with 6, but we have only 5 spacing here. 1, 2, 3, 4, 5. Why do we multiply it with 6? Because we have spacing by 2, S by 2 at this end, S by 2 at this end. So this 2 will add to give S. So we have total 6 into spacing. So we multiply with 6. Now this RA is acting at a distance S by 2 from the last disk. S by 2 is this distance, this is S, and this is again S by 2. So what will be the total What will be the value of RA and RB? We will first find. This RA and RB will be equal. So RA plus RB is equal to all this V. Total 6V is there. 6V and weight of this gang is there. That is WG. So one RA, either RA or RB, what will be the value? It will be this value by 2. That has been done here. Total vertical force is 288 into 6. And what is the weight of one gang? Total weight of total gang by 2 will be the weight of one gang. So C, weight is acting downward and V is acting upward. And what we discussed earlier, that weight was greater than V. So what will be the reaction force? W weight minus this Vt by 2. Kamlesh and Vans, do you have any doubt from here?
No, sir.
No, sir.
Okay. So it will not be 6V plus Wg. It will be Wg minus 6V. This by 2. So this value is coming as 162.3 Newton. This value is 162.3 Newton. And what will be the moment acting on this? Due to this V and W, this gang will have, this shaft will have bending moment due to this W and this V. This W and V will try to bend this shaft. So what will be the bending moment? We will calculate bending moment with respect to this line, middle of the shaft. From here, RA is trying to bend this shaft. Which side? In which direction? Clockwise direction. And V is also trying to bend it in clockwise direction. And W is trying to bend it in anti-clockwise direction. So if we take RA and RA one thing positive, suppose RA and V we are taking as positive value. So RA is working at a moment arm of how much distance? This is S, this is S. And this is S by 2, S by 2. Total 3S. So 3S is the moment arm for RA, and this V is working at a moment arm of S plus S plus S by 2. That is 2.5S. So this V is acting at 2.5S into V. This V is working at 1.5 V, and this V is working at 0.5 V, 0.5S. So what is the total S? It is 4.5. So this is 4.5S. So this we calculated, this 3V in clockwise direction, this R in clockwise direction, and what is left here? WG. WG will be negative because it is in anti-clockwise direction. So one minus sign is here for WG, and it is acting at a distance of this S and S by 2, that is 1.5 S by 1.5 S. So this is the value of moment arm, bending moment, which is acting, which is trying to bend this shaft. So that value means RA we have already calculated, as we know. WG we already know. So if these are all known value, so MS we can get from there. So MS will be 35.9 Newton meter. Now here torsion moment. Torsion, what, which force will try to twist this shaft? That you need to tell. This is the shaft. This V and W is trying to bend this shaft. And which force is trying to twist this shaft? The draft force will try to twist this shaft. But we need to divide it by cos alpha. Why draft force? Suppose this is our disk harrow 1 gang. This force will, this twisting force, this is the draft force, and this will be the moment force. This is our gang angle, beta or alpha, anything. So this angle will be equal to this angle. Now, what will be the moment? What will be the moment force that will try to bend this shaft? This m by m into cos beta will be this shaft, this draft. M into cos beta will be draft value. So, what will be the value of m? M will be draft by cos beta or cos alpha. So, this is the value. N1 is the number of disk in one gang. N1 into draft by cos alpha, and this will act at a distance of r is the radius of r is the radius of disk, that is diameter by 2 minus a by 3. At this moment arm, this twisting force will act. So this torsion moment we will get as 448.16196 Newton meter. This is our torsion moment and this is our bending moment. Now as we have these two moments, this design equation from strength of material we have studied in, we must have studied in during BTech course, that sigma is equal to my by I, where sigma is what? Sigma is design stress, m is the bending moment, y is the distance at which that force is acting, and I is the moment of inertia. Here sigma b is equal to m for a square section. This y value is b by 2, and this moment of inertia is b square b to the power 4 by 12. We need to find that this b value. If we are if we are designing it for a square section, if we are getting that b value, means we will complete our design. And for square section, polar moment of inertia, for torsion moment, this is for bending moment. This sigma is the safe limit for bending, and tau is the torsion moment, where ts is the torsion moment, b by 2 is y, and this b square b to the power 4 by 6 is the polar moment of inertia. In case of torsion, it is t y or r, tr by j, and in case of bending moment, it is sigma is equal to my by I, and in case of torsion moment, tau is equal to tr by j. If we have this bending and torsion both at any section, square or rectangular or cubital, any section, this, if we have both this force, then tau max we will use as, then tau max formula is this, means 1 by 2 root under sigma square plus 4 tau square. This is the equation we will we need to use if we have both bending and torsion moment. So our sigma is this value and tau is this value. So tau max, this will be the design of any material, or design stress of any material. Suppose for this is for mild steel, then tau max will be 150 megapascal. So tau max is with respect to what material we are choosing, and these are the values we need to calculate. From here, everything is in b value only. Here, everything you can see. So from there, in terms of b, tau max we can get. So in terms of b, we have this formula, and if we will put all the values here, we know km, ms, ts, tau max. So we will get that, we will get b as 3.4 centimeter. So 3.4 centimeter will be the shaft dimension. 3.4 centimeter, 3.4 centimeter, this will be the square shaft that will be there, and on this shaft discs will be mounted. Now you revise from here to here. If you have any doubt, you can ask. If you have understood till here, this question you can make. The gang angle of single acting disc harrow is 22 degree, while diameter of disc and depth of operation is 56 centimeter and 12 centimeter. This is diameter and this is depth of working. Draft on each disc is 300 Newton. Assuming the soil reaction force to act at the edge of disc, total torque acting on the each gang due to soil reaction in Newton meter each. Basically, you need to find the torsion moment. Just now, I have discussed that thing. Everything is given: disc diameter, depth of working, disc angle, and draft. And draft is given. From draft, how to calculate this torque acting or torsion moment? You need to find that. Calculate this value. I was coming. Have you calculated Kamlesh once?
No, sir.
Okay. This is the draft value. Just now I discussed that. This is the draft value. We need to calculate torsion moment. So this force we need to know. So this moment force, that is denoted by m. M cos beta will be our draft force. M cos beta is draft. So what will be that moment? Moment will be is equal to draft by cos beta. So what is draft here? 300 Newton. 300 Newton by cos beta. Beta is 22 degree. That is gang angle. This will be the moment force. And first do this. The gang angle of a single acting disc harrow with 6 discs in each gang. While diameter of disc angle is this. Draft on each disc is 300 Newton. Total torque acting on each gang we need to find. See, this is the draft acting on each disc. This is the draft acting on each disc. And how many discs are there? 6 discs in each gang. So at one gang we have 300 Newton draft. So 300 will be at each disc. So 300 into 6. This will be the total draft by cos beta, cos 22 degree. This will be the moment acting on this gang. And this gang, at how much distance this force will act? This cos, this draft by cos beta is acting at how much distance? At the tip. If this point is not given, assuming the solid reaction force is acting at the edge of the disk. If this is not given, then we will have to use that formula. R by a minus 3 something was there, which we discussed earlier. But it is saying that this force is acting at the edge of the disc. So edge of the disc means this is the disc diameter, and at this point it is acting, and the shaft is here. So this will be the radius of the disc. So this force is acting at the radius, means d diameter is given, means d by 2 will be the radius. So d is, we have to calculate in meter. This is 56 centimeter, means 0.56 by 2 is in meter, and we need to get this in Newton. It is already in Newton, 300 Newton. 300 into 6 by cos 22 degree into 0.56 by 2. This will be Newton meter. Calculate this value. We will get one of these four options.
It's it's 543.58.
543.58. Okay, that is correct. For first question, the answer is B. Now moving to second question. The depth of operation of a single acting disc harrow with 5 discs in each gang. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 discs in each gang of diameter 51 centimeter. Depth of operation A is 10 centimeter. Gang angle is 25 degree. Beta equal to 25 degree. Assuming ridge height is same as depth. Ridge height we denote as C. But in this case we are taking C is equal to A. So ridge height is same as depth of operation. The minimum length of shaft for each gang in centimeter will be. Length of shaft we need to find. This length of shaft. One shaft. Length of shaft will be equal to what? Minimum length of shaft it is asking. So first we need to find what is the spacing. For spacing we have a formula. Spacing is equal to 2 root under a into d minus a. The formula, actual formula is 2 into c into d minus c. C is the ridge height, but ridge height we are taking as depth of operation. So ridge height we will calculate. From ridge height we will calculate. That is 2 into root under a into d minus a. So the spacing you can get into tan theta is there. where theta is the gang angle. This space for this spacing this is the formula 2 into a into d minus a into tan theta. So this is 10 centimeter 51 minus 10 into tan theta. Theta is 25 degree. This will come in centimeter. What value you got? 2 root under 10 into 51 minus 10 into 1025. This value what you got once?
Sir, I am getting 18.88.
18.88. Okay, we will check this. And this is 18.88. This is spacing. And they are asking minimum length of shaft. Minimum length of shaft will be this one. This is extra. This side is extra. So minimum length will be 18.88 into 1, 2, 3, 4. 18.88 into 4 will be minimum length of shaft.
It is
18.8,
75.5.
75.
75.3.
Okay, 75.54. This is the answer. Have you solved week 1 question? This year's week 1 question?
Yes, sir.
Okay. Uh, you solved every question.
Not every question, but I tried.
Which question was left? Like I think what we discussed, everything will be was approximate similar only. Like that session, last session was helpful now for solving that question.
Yes, sir. Yeah, last session was helpful, but I'm still like learning and having like in a learning phase. So I am having some difficulty because it's everything is new in this.
Oh, okay, okay. This week also it will be like easy for you if you solve these questions. We are discussing here. Like you will solve all the questions for week 2. So 75.454 was the answer for this. Now third question is if the diameter of disc, spacing between two adjacent discs and width of cut of an offset disc harrow are 51 centimeter, 15 and 102. Means diameter of disc is 51, spacing is 15 centimeter, and width of cut is 102 centimeter. The number of disc on each gang. Now for this, what is given, width of cut is given, and width of cut we have discussed that for width we have some standard formula, is standard, bis or asabi standard. So we will follow one standard. This we discussed in starting only. So here we discussed that suppose this standard we will use. What was the question? Which disk single acting, no? Offset in an offset disk arrow. So for offset disk arrow, This is the formula. Width of cut is this, and for Asabe, this is the formula. So which formula to use? See, this formula is same only. Here it is n1 minus 1, everything is same. Here it is n, but n is the number of disk spacing and n1 is the number of disk. So it is same. Suppose we use this formula, 0.95 into n minus 1. You tell that formula, I will write it here. 0.95 into n1 minus 1 into s minus 0.60 plus 0.60, and 0.95 into n1 minus n into s plus 0.6 into d by 100, and s is in centimeter, d is in centimeter. We will get this width in meter. So width in meter will be this plus 0.60 by 100. This is n1 minus 1, means this is number of disk spacing. This is number of disk on each gang. So number of disk on each gang is number of disk on each gang. We need to find this n1. We need to find n1 minus n will we will keep as it is. Width of cut is given. Width of this cutting width is given 102 centimeter. So 102 centimeter is given. This value is in. So what will be in meter? It will be 1.02 meter. Will be this value. Width of cut 0.95, n1 minus 1, d is diameter is 51 plus 0.6 into s is the spacing. Spacing means 15 centimeter. 15, 0.6 into 51. This by 100. So 100 will come this side. It will again become 102 centimeter. So this value is 102. Means 102 minus 0.6 into 51 will be equal to 0.95 into 15 into n1 minus 1. Calculate this n1 value. What value you got? Once.
So I'm still
Okay.
calculating.
Okay.
Sir, it's 6.
Okay, means the answer will be 6 here. So these are the problems, and we and this will clear, like this will make everything clear for you. All the disk concept will be clear if you have understood those three problems.
Sir, why we are not using IS BIS standard, that first one?
Yes, this is same thing only. This here it is n and here it is n1 minus 1. Everything is same, but only they have used this is number of disk spacing and this is number of disk. So it is same thing. Suppose there it was 5 disks. Answer was suppose six it came. Means what he got the answer that was 6. Means n1 you got at 6. But if we used that n BI standard, we will get the answer as 5. So we will get the answer as 5, but that is number of spacing. We need to increase, we need to again add one disk, one more number to get number of disks. That is just a spacing. Suppose there are 3 disks, so spacing will be 2 only. So this we will get from BIS. We need to add one more value to get number of disks. In BIS, this spacing is given n. Am I clear?
Yes, sir.
Okay. So we have also designed a disk harrow. Design of shaft is clear. This design of shaft, if you have understood, you will get like a whole lecture series. Like everywhere it is same only. In cultivator, in rotavator, everywhere this concept is there. This whole concept is there everywhere. This bending moment, torsion moment, shaft. How do we get those values? Everywhere it is similar only. So if you have any doubt from this design of shaft, you can ask. And for design of frame also it is similar thing. See this formula we have discussed. Tau max will be if we have both bending moment and torsion moment, we will use this tau max formula. We just need to know that which force is trying to bend something and which force is trying to twist something. For frame, this RA here, RA and WG value will try to bend the frame. And torsion will be due to draft. It will try to twist the shaft. So from that concept we will proceed, and again we will get like for what will be the bending moment. This RA is acting at a distance of 3s, s zero point 0.5 s, zero point 0.5 s, and WG by 2. Here this is the bending moment acting on the shaft, and torsion moment will be due to draft, and it will act at this distance. From here we will calculate this bending moment, torsion moment. Again this sigma b, tau max, sigma b and tau, and from sigma b and tau we will calculate tau max, and again we will get some a value of b. So b from here will be 4.757474. This will be the design dimension for frame. And similar we have studied for shaft. So if that up to that is clear, means our design of disk harrow, disk block is clear. You can if you will go through the lecture you will get the similar thing. So second thing is spike tooth harrow and cultivator. So spike tooth harrow, you can see this is a spike tooth harrow. These are the spike tooth harrows. And how do we calculate it's the distance between the spacing between these two tines? Suppose it is working at a depth of a, and this is angle of internal friction of soil, is it is delta. So this is perpendicular for this triangle, and this is base, that is depth of or depth of operation. So this is This value will be 8 tan theta, 8 tan delta. This is 8 tan delta, and this thickness is d, and this is again 8 tan delta. So 2a tan delta plus d, 2a tan delta plus d. This will be this will be the working zone of one time. Now this is the how to arrange it on a frame. Suppose this is a frame. If we are mounting it on at an acute angle, suppose this is moving in this direction and this is time. In this direction it is moving, so it will make from ground, from in direction of travel, it will make this angle. This is an obtuse angle. We can also make it like this. Here it will, in this diagram, in this motion, it the force, the soil reaction force will be downward. Here it will be in this direction, and if we are mounting it like this and we are moving in this direction, then soil reaction will be in upward direction. Means here draft will be minimum, but in this case draft will be minimum, but it will try to throw this tine in outward direction, in upward direction. So if we want a better penetration, this angle is called setting angle. This setting angle should be between 70 to 110 degree. So here it is asking that setting angle of teeth of a spike tooth arrow can be changed within the limit of 70 to 110 degree will be answer. Now second thing you see here. In case of a spike tooth arrow, which of the following condition gives more depth of penetration? Just now we discussed. More depth of penetration will be in this case. This case is which option? You tell me. For better penetration, teeth set an acute angle with respect to ground. Teeth set an acute angle. Suppose this is teeth. Now this is the option A. This is acute angle. If this is the direction of motion, this is making acute angle with respect to direction of travel. This is with respect to ground along the direction of travel. This is acute angle. So acute angle was through. It was not giving better penetration. It was trying to lift the time. So if it is making obtuse angle with respect to ground, then it will give more depth of penetration. So option B is correct. Operating zone we discussed. Now this transversal spacing of time. This spacing should always be greater than the TS zone. That is operating zone that we were discussing, 2 a 10 delta plus D. So this transversal spacing should be greater than this thing. Means delta T should be added in this. 2a max plus D plus delta T should be added, and that should be the transversal spacing. Why that should be there? Because where zones of excessive accumulation of soil If we are not giving this much distance, then accumulation of soil will be there. Excessive accumulation of soil will be there. So to avoid that, transversal spacing T naught should be greater than the zone TS. And how we arrange that those tines those tines on a frame, it is arranged on a multi-coil helix type construction. So suppose this is where those tines are arranged. So the place while placing of tines in a harrow section, maximum spacing should be provided to avoid overlapping of traces. Suppose this one tine is here, one tine is here, one tine is here. This is everywhere where it is in intersection. One tine is there everywhere. So this between these two there should be maximum spacing, else this will overlap. This tine and this tine will overlap and it will become meaningless. So one on one time some other time is coming. To avoid that thing, one design procedure is there, and there should be maximum spacing should be provided to avoid overlapping between those traces. One time will go in this line, second time which is coming from behind will go in this line, one time is there. So for every time there should be some space, it should not overlap. That should be our primary thing to consider. So for that we design this spacing in a zigzag shaped arrow. This is a zigzag shaped arrow, and k is the number of spacing here. This spacing which we are discussing above, k is this number of spacing, and sz is the spacing between two disc, two arrow. So from here to here, suppose k, k is the number of spacing and m is the number of row of teeth. This row, one row, second row, third row, fourth row, fifth row. So this number of spacing and k, this m and k should not have a common divisor. Suppose if we have suppose 5 number of rows of teeth, so k value should be 2 or 3. There should in this you can see there is no common divisor. If we are taking 7 rows, then k value should be less than this 7 value, and there should be no common divisor. 2, 3, 4, or 5. We cannot take, if we are taking suppose 6, then we cannot take 2, 3, because this will have common divisor. So first thing is that there should be maximum spacing should be provided to avoid overlapping of traces, and number of spacing, that is k, and number of rows, that is m, there should be no common divisor, and m should be greater than k plus 1. In that way we can design a zigzag shaped harrow. So if we, and this from here cultivator is starting. So this cultivator we can also discuss, but if we will see some harrow questions first. Suppose next question is, which of the following statement is true in case of a spike tooth harrow? Transversal spacing of tines must always be greater than width of failure zone. The number of spacing and number of rows of teeth should have common divisor. While placing tines in harrow section, minimum spacing should be provided. Number of spacing must always be greater than number of rows of teeth. See, number of spacing and number of rows. Number of rows is m and k. Number of spacing is k. Number of rows is m. And m should be greater than k plus 1. Number of rows should be greater than k plus 1, and k and m should have no common divisor. So this statement is they should have common divisor. So this is wrong. While placing tines in harrow section, minimum spacing should be provided. We studied that maximum spacing should be provided to avoid overlapping. So this is also wrong. Number of spacing should always be greater than number of teeth. This is number of spacing is this one. This is great. This should be greater than number of teeth. That is wrong. This number of rows should be greater. Number of rows of teeth. This should be greater than a number of spacing. Here the statement is opposite. And what is this statement? Transversal spacing of tine must always be greater than width of failure zone. Transversal spacing means this is the transversal spacing between two tines. This was the working zone of one tine. So we studied that this was the working zone of one tine. So this spacing should be greater than working zone of one tine. Else there will be no meaning. Like one accumulation of soil will be there. It will overlap. One tine will come from one time will come and second time will also come and it will overlap. So the transversal spacing should be greater than width of failure zone. So this statement is correct. Understood? Next question is for a cultivator with sweep type working element. This is a cultivator. This is a cultivator if this this time can be rigid type or spring type. So and this is load angle. This is working element with respect to ground. It is making an angle that is a load angle. And this is maximum deflection F. In case of spring time, it will deflect, and this maximum deflection is should be less than 10 centimeter. Load angle in case of shovel or sweep type, it should be less than 30 degree, and load angle in case of shovel without spring deflection should be 15 to 20 degree. If that shovel or sweep has spring, then it can be less than 30 degree. And if it is with without a spring, then it this load angle should be only 15 to 20 degree. Advantage of using a spring time this. So and this thing we have discussed in case of uh, spike tooth arrow also. This is the working operating zone. This is the spacing between two tine. This will be a maximum. A maximum will be 8 10. This angle 5. 8 10 5. This is 8 10 5. So this will be 2 8 10 5. This whole thing, and plus d you can add the width of one time. This will be the width operating width, and this delta t we must add so to get this transversal spacing t naught. So t naught will be 2a max plus b naught plus delta t. And in case of sweep, this is called apex angle. 2 theta is the apex angle. Apex angle of the point of survey should be between 70 to 90 degree. So if we come to question, for a cultivator with sweep type working element, the condition for easy cutting of roots of widths is apex angle should be equal to 90 degree. Apex angle should be from 110 to 135 degree. Friction angle should be more than 45. Apex angle should be less than equal to 90 degree. This we just now saw that apex angle for shovel should be between 70 to 90. It should be less than equal to 90 degree. So for this question, the answer will be apex angle should be less than equal to 90 degree. Suppose next question, penetration of disc harrow can be increased by. Disc harrow penetration can be increased. Increasing the weight of implement, increasing the disc concavity, sharpness of disc from convex side, all of these. Increasing the disc concavity will not have any influence on disc harrow penetration. And sharpness, if we increase sharpening the disc from convex side, will also poor the penetration. If we sharpen it from concave side, then it can increase the penetration. So but if we increase the weight of implement, it will have better penetration. And if the time, this is the time, this is the working element. Working element has suppose it is of height a max, and h1 will be the clearance between working element and this is suppose shaft, up to shaft's bottom thing. It if the height is h1 and shaft has width of delta h, then what will be the height of this tine? This tine will be height of delta h plus h1 plus a max. This is the design for tine. So a max plus h1 plus delta h will be the height of sank. So height of sank of a cultivator is 450 mm. This total height is 450 mm. And minimum clearance between land surface and lower edge of the frame. Minimum clearance between land surface and lower edge of the frame is 280. This is 280. If the length of upper part of sank is 50 mm, the depth of operation of cultivator A max you have to find. It is just simple one. This is 280. This is 50. This is 450. 280 plus 50 is it is 330, and 450 minus 330 it will be 120. So 120 is the answer. And last question is which of the following statement is true in case of sweep type cultivator? Load angle of sweep should be kept 30 to 38 degree. What should be the load angle of sweep? Load angle of swivel or sweep should be less than 30 degree. And first statement is load angles of the sweep should be 30 to 38 degree. And we have studied that it should be less than 30 degree. So this statement is incorrect. Second is smaller load angles are kept for sweep of spring teeth while larger angles are taken for rigid teeth. Smaller for spring and larger for rigid. Here you can see load angle of swivel without spring 15 to 20, and with spring it can reach up to 30. If we have spring there, then we can increase the load angle up to 30 we can go, but without spring it should be 15 to 25. But what the statement is telling, it is telling that the smaller load angle are taken for sweep for spring. That is incorrect. Smaller load angle of are taken off sweep for spring is incorrect. Larger angle is for rigid teeth. Larger angle is with spring, and smaller is for rigid. Cutting angle should be in range of 8 to 10 degree, and angle of sharpness lies between 20 to 30 degree. Cutting angle and angle of sharpness. Cutting angle should be 18 to 30 degree. You can note down. Cutting angle should be 18 to 30 degree, and angle of sharpness should be 20 to 12 to 15 degree. So if we consider these two statements, in that case all four statements will become incorrect. So I think this question I will tell to sir. Up up to here it is clear. This question I will tell you, like I think there is some mistake here. Once Kamlesh, have you understood whole class?
Yes, sir.
So if you have any doubt, this will help you solve all the questions of week two. You will not get any doubt. Week one also, if you, I think both of you are once had solved, I think, but Kamlesh, have you solved week one question?
Yes, sir. I have tried to solve by myself only.
Oh, last week you were not there, na? You solved week two question, then you tell me that if you are, do you have any doubt or not?
No, sir.
No, like week two assignment you will get now if you have registered for exam. So uh, you have registered for exam, na?
Yes, sir. Yeah.
You give exam for week two and tell me that was it helpful or not. Like in same way we will discuss week three and next Monday 6 to 8. This was the whole like whole week two we have discussed here in this 1.5 hours. So once have you started week two at there like NPTEL videos have you started?
No, sir.
Okay, you see also there, and if you have any doubt, you tell me here. If you don't have any doubt, then we can end the class here.
Thank you, sir.
Hello, sir.
Come. Uh,
May you please share this PDF, sir?
um, yes, this I will share the link in this chat. In
Okay,
next
I
class,
can.
in next class I will share the chat. In the chat box, I will share the link for this PDF.
If you can share this PDF now, sir, I will download it and do some practice.
Okay, I will upload this in Drive. Then I will share the link here.
Yes, sir. Okay.
Okay, okay.
Ji, please. Thank you.
Okay, then we are leaving.
Okay, sir. I will wait for your link, sir.
Okay, I need to upload whole class. I will. Okay, you give me your email ID. I will mail you.
Yes, sir. Please note down.
Mm, yes, yes. Please say like
Narender, Narender,
NARENDER
@
at the rate
AU Jodhpur,
AAU Jodhpur
AU Jodhpur
AU Jodhpur
.ac.in.
.ac.in.
एक बार रिपीट करेंगे मिल गई.
ये मैसेज सेक्शन यहाँ पे है मैं उसमें लिख रहा हूँ एक बार नरेंद्र @AU जोधपुर
A for
डॉट ए सी.
agriculture, U for university. हाँ, AU Jodhpur .ac.in. जी जी.
ओके थैंक यू लाल कमलेश ओके okay Kamlesh and once I will send you people also okay then we are leaving. We'll meet next Monday 6 to 8.
Okay.
गला तो सूख जाता है पूरा, पता नहीं कैसे निकला उसमें।